Hi everyone, this is Mishal Salim and today I'm here with another practice question for A-level mathematics, which is from the topic proof by exhaustion. So the question is, if n is an integer, so let me write n is an integer that is not divisible by 3. So if it is not divisible by 3, it means that it is not multiple of 3. Okay, so what would a multiple of 3 look like? It would look like 3k. Okay, multiple of 3 would look like 3k. K is an integer, is a number. Whenever 3 is in multiplication with a number, it will definitely make it a multiple of 3. So we don't want a multiple of 3, so just add 1 to it. So now it's not a multiple of 3. Okay, there is another possibility as we are discussing proof by exhaustion. 3k plus 2. You can also try this, you can also use this. And we can't use 3k plus 3. We can't use 3k plus 3 because it would make the number again multiple of 3. When you multiply a number with 3 and then again add 3 to it, so it is still the multiple of 3, because if I put 1 instead of k, so 3 times 1 is 3, 3 plus 3 is 6, so 6 is multiple of 3. But if I give one value to this k, to 3 times 1 is 3, 3 plus 2 is 5, so hey, it is not multiple of 3. And in here then if I try to multiply 1 with this 3, so 3 times 1 is 3, and then 3 plus 1 is 4, so 4 is also not multiple of 4. So now we can't use this one exactly, obviously, so we won't be using this one. Let's cross it. We can't use this one. Okay, now moving on, I'm gonna do something about these two. Okay, so they're asking that show that n square minus 1 is a multiple of 3. So n square minus 1 is a multiple of 3. Now I'm gonna show them that n square minus 1 is a multiple of 3 by using these values of n, these two values. Okay, so let's try the first one. So the expression is n square minus 1 equals, so use 3k plus 1 instead of n, so 3k plus 1, and then square it. So by squaring it, okay, now minus 1, this one minus 1, this. Okay, so let's simplify it. Let's see what do we get. Okay, so it is actually a formula that is first plus second whole square, so it will become first square plus second square. So I'm going to write the first square, second square in the last, and I'll write the second 2 times of first and second. First 2 times of first, 2 times of first into second. Actually by first and second I mean the first term and the second term. So the first term is 3k and the second term is 1. Remember this. Okay, now the 1 and then plus second square. So okay, and now minus 1. Now you will know in the next step that why I write the second square at the last. Okay, so 3 square is 9, and then square on the k will make the k square, plus then 2 times 3 is 6, so 6k, it will become 6k, and then plus, so 1 square is 1, and then minus 1. That's why I wrote the second square at the last, so that I can cancel these two easily. for you to see easily and for you to understand easily. So these two will be cancelled as they give us the result 0. So here we left with 9k square plus 6k, and we can factorize this by taking 3 as common. So it will be then 3k square plus 2k plus 2k. And hey, the first value has been verified as the bracket is in multiplication with 3. So it means that if the value of n is 3k plus 1, then n square minus 1 is definitely multiple of 3. So that's one thing. Okay, now let's try this another value, and I will try it here, or let's just try it down here. Don't make it messy. Okay, so n square minus 1 equals, now I'll use the second value, that is 3k plus 2 whole square, and then minus 1. This square is because n has square, this is the value of n minus 1, so minus 1. Okay, now in the next step I'm gonna open this formula, which is first plus second whole square. So first plus second whole square is equal to first square, it is first square plus twice of first times second, then plus second square, and then minus 1. Okay, so 3k whole square, so square is on the 3 and on the k both, so 3 square is 9. Okay, and then k square is k square, and then 2 times 3 is 6, 6 times 2 is 12, so 12k plus 2 square is 4, so 4 minus 1, and 4 minus 1 is actually 3. So I'm gonna skip one step and I'm gonna just write directly 3 here, so it will save us writing another step. And in the next step we will directly take 3 as common factor, as these 3 terms has numbers that are multiple of 3, 3, 12, 9, both are multiple of 3. So let's take 3 as common factor, factorize them. So here we will be left with 3k square, and in the next term there is 3 times 4 is 12, so 4k, and then 1, so 3 times 1 is basically 1. Okay, so by the second value we've also proved that yes, n square minus 1 is multiple of 3. So by exhaustion method we successfully proved that n square minus 1 is multiple of 3, because this thing shows us that this thing is multiple of 3. Whatever this gives us will be multiple of 3, because something multiplied with 3 is definitely multiple of 3. Something multiplied with 3 definitely multiple of 3. So whatever comes out of this is multiple of 3. Sense proved. Thank you.